As where y'all are in the young Earth, old Earth spectrum of possibilities, is there like people who are young Earth? Are you going to raise your hand?
Could we define that?
Young Earth would be people that believe the Earth is 6,000 years old, or maybe
6
less
to
than
10,000.
6 to 10, yeah, on that order. As opposed to old Earth, where we're on the order of 4.5 billion years old. So that's the definition. Anything more finer than that is not doable. So anyway, but so if you find yourself young Earth, old Earth, or are you in the fence?
Middle Earth.
Yeah.
Middle Earth. Yeah, there you go.
Wait, that one sounds.
Middle Earth.
I lean more towards old Earth.
Yeah. Okay.
I just do what I always say, don't charge me after Dr. Ray J. So I just send them your way.
Not necessarily a good idea, but thank you. Yeah. Yeah. Okay. Well, for myself, I'm older, but I tell you, I've been on both sides of the fence several times. I started out young Earth as a child, went through, periods. I love science and so forth. It was a rock collector from a long time ago. In fact, I tell my story. My mom took us to an independent fundamental Baptist church, is what I grew up in. So it was Miller Street Baptist Church was the first church. I was 8 years old when we started going in Burleson. It's the church is gone now, but it was over there by Booger Creek, which is just across the highway on 35 and out that way. And at the time, we were doing the traditional independent Baptist thing. You do Sunday morning Sunday school and church, and a Sunday evening church. You got Tuesday visitation, and you had Wednesday night services as well. Bus ministry on Saturday. So it was like a full-time thing. But 8 years old and thereabouts, the pastor of the church, I'd be listening to him on a Wednesday night, pounding on the pulpit, talking how Darwin filed those bones down to tell the lie of evolution. And I got indoctrinated with all of the fire and brimstone stuff that comes from the Baptist upbringing. Now, what would happen is that after the services, my mom would want to talk to everybody, be visiting. Well, I'm a boy not interested in that, and so right across the dirt road was Booger Creek down the bottom. So I found myself and a couple other guys, we go down there playing around in the creek bottoms over there while we're waiting for our parents to get ready to go. And there, of course, we come across a lot of fossils you can find even to this day. I didn't bring any samples today, but immediately I'm already in a dichotomy. Trying, how do you explain the fossils here versus what did he say up there? Now, the long and short of it is I've spent now 50 years, or there about 45 years now, basically on both sides of the fence, sometimes on the one side or the other. Now, where I'm at now, and have been for some years though, is on the old Earth side. But I find myself trying to balance that with the respect for the scriptures that I grew up with and still have to this day. And so I have been looking too, like everybody else, to try to find ways to reconcile these things. So with that kind of background, everything I got to show here today, I've got lots and more than we'll be able to get through. So I'm a little bit more interested in seeing some of maybe the expectations that you have. I've got different kinds of material here, and it falls roughly into 3 different classes. There's worldview concepts, and then how that plays into our culture and our society, especially a Christian worldview versus the materialistic worldview that we've got today. We can talk some of that. There's, of course, the evidence from a scientific perspective. Well, why do you think the Earth is old? And then, of course, the young Earth perspective, the arguments that are for that. But I got to tell you, since I am old Earth, and I've heard all the young Earth arguments, I'm going to be leaning that way. And so you're going to get that, even though I'm going to try to be as unbiased as I can, having come from that camp too. So there's that as well. And then there's some solutions. Was that a child or a dog?
Yes.
We do have 3 children in the room in there, but that was none of them.
It was none of them, okay. And then the last part is trying how to reconcile some of this stuff. You find how do you reconcile the Bible and what we read in Genesis, for example, to the older stuff. So is there some favorite element you'd like to start with? Like a burning question in mind, or you need to wait a little bit? Y'all give me some feedback. If there's nothing going to come up immediately, going to snap to, let me go ahead and start with a little bit of the material. Yes, Kendall?
We've sat through this when we did the college group. Where would you, dinosaurs. Where does that all come in?
Yes.
From the tip of my tongue,
Yeah.
too.
What do you do with the
Yeah,
dinosaurs?
we eat the dinosaurs. We build a whole count of them, or lack thereof.
Yeah.
And that's all.
Yeah, okay,
That's all.
well,
Because then my mom was like, the Earth has a history, like was created, like I think my mom is a young Earth,
yeah,
and she said like something she said once was like the Earth was, or she likes to believe that the Earth was like made with a history. So that's, and I was like, I don't get that, but
yeah, like the appearance of age.
Yeah.
Those kind of arguments,
Yeah.
they're walking through that. Okay, that's more on the geology side of it, and so let me kind of
but I'll let you do your thing.
walk through some of those arguments here. Let me see where they pick up here. That's astronomy.
Because I thought the astronomy part was really cool.
The astronomy part too. Okay, let me give you sort of an overview parts to this here. We go. I think it's this one here.
Now, if we need to, we can make this into like a 12-week
Yeah.
study.
Yes.
Oh, I love that.
Yeah.
The first sessions that I would do was on material worldview versus biblical view, why we agonize over this. But that doesn't seem to be where you guys are at right now. The other one is, let's see, on creation, evidence of an old universe, and why we agonize over. Oh, that's the other one. Let's see. Let me make sure I got these in the right order. Now, I'm going to talk geology first. So let's go ahead and start with, why do people think the Earth is old? And we'll start in geology. And the arguments that I use have to do with the trying not to confuse people with so much that's out there, as far as all the different debates that are on. I have looked through like a million different podcasts and YouTube videos. You've got your Ken Hams, you've got your Ken Hovens, you've got Hugh Ross, and you've got Ken Miller in the theistic evolutionary camp. There's a whole host of different ones that talk there, and they'll have their debates on either side. But I'm going to go ahead and cut to the chase and just talk Earth geology right now, and hopefully it'll spawn more questions. And kind of work through that. Let's see, Younger Challenges of Geology. Is this the one? Let me just walk through the slides and make sure I got the right one. Yeah, okay. Some of the aspects that come into reconciling the Bible to the geology that we find it is the idea that the flood geology of Noah's flood is able to explain all the geological features that we find around the earth. That's a very dominant viewpoint from the young earth creation scientists. The Henry Morris and the Creation Institute, they're located in Dallas. They used to be in California. They have been the most influential as far as trying to make arguments to show that scientific evidence shows that the earth really is young. The scientists themselves that don't believe that are either biased, prejudiced towards an atheistic world viewpoint, materialist viewpoint, and therefore reject it, and they're blind to seeing that evidence in the correct light. But I will tell you, honestly, it really doesn't work that well. And what I hope to do is just kind of show you why there are problems with that kind of idea, that in fact the earth really is young, but they just think it's old. And this is where some of the evidence comes from. Flood geology is the idea of catastrophism. There was this global worldwide flood that so destroyed the face of the earth and reconfigured it. There's nothing of the old way it looked, and what we see now is all a result of the flood. All the geological features of the surface of the earth are explained by Noah's flood. However, they use the Grand Canyon as a typical example. Some things cannot necessarily be adequately explained using flood geology, and that's really the core of what I wanted to talk about. They'll do a lot of hand waving to say that, oh yeah, you see this mountain, and it had to be all this stuff kind of blew in here, or the big Grand Canyon ate it all away in just a few days or whatever. But okay, maybe for those things, but there are so many other things that occur in the world that we observe, you can't explain by flood geology. So let me just give you a few examples. These atolls, for example, we're going to talk to. There's seafloor spreading, local Texas geology. What I tried to do is get away from the evolution arguments, fossils, where the dinosaurs fit into it, but rather let's just talk what's called structural geology. It's called geomorphology. It's the morphing is the the shape of the land that we find around us. And how do you explain that? This picture here is from James Hutton's first discovered, or his aha moment, about the idea that in fact the geology and what you see like on the coastlines cannot be explained in one flood. And this rock pile, this formation, is the one that he saw, and that after many years of cogitating, he thought it over. In this formation, in the region, there was at least 3 major mountain building events, strongly suggesting the enormous age of the Earth and the inadequacy of a single flood as an explanation for origins of this formation. Do you see it? When you look at that right there, are you seeing what he saw?
Seeing the rock in the different, going the different
Yeah.
directions.
Yeah. Yeah. If you look close, if you observe, you'll see a couple of things. I don't know if you can tell in this picture so closely, but if you walked on it, these beds are almost vertical.
Okay.
But right here, you see these beds are going horizontal. So what happened here? At one time, these are layers of sandstone, and we know that by gravity, sandstone deposits kind of level and flat, like you see in the lake bottom, on the ocean front. So first, those sands had to be laid out, layers of them. Then what happened is this lithified, it turned to stone. It had to be lifted up vertical or something like that, at least above where it could be eaten away. All of these beds here, or this part right here, it's called an unconformity, were ate away in erosion. Then it submerged, and these layers of rock were parallel and were laid down. And then that whole thing was uplifted again and is now weathering away into what you see now. So there are 3 different events. So how long does it take to lay down those beds of rock, turn them to stone, flip it up, erode it back down again, submerge it, redeposit another layer, let those turn to stone, flip it up, and then erode that down to where you see now. That was his aha moment. Now what I want to do is show you
Yeah.
other examples of that.
A couple of years. So.
Yeah. 20 minutes. 20 minutes.
20 minutes.
The other great geologist of the days was Charles Lyell, who concluded he was looking in the both of these guys, along with many other geologists back in the 1790s, were trying to fit geology into Noah's flood. That was the diluvianist idea is the premise that okay, all of this stuff has to be explained by the catastrophic events of Noah's flood, and they were having trouble. John Hutton was one. Here's another one. This is Charles Lyell, and what he was doing, he was in a valley and excursion through France, and he came across a set of formations like this, where there's these layers of rock that were going this way, and it's a riverbed that's here. Down in the riverbed right now, there's all that's called channel lag. It's all that gravel that you see in the bottom of a riverbed. It's all getting pushed downstream, rounded off, and so forth. You looked up on the side of the hills, though, you found the same thing again. There's this gravel bed, and there's a lava flow that was above it. And then above that again is another one. Now, when you look at this and you study the history of it, this represented 3 different erosion type events. There, at one time, sort of the ancient river was up here. The lava flowed across it, but it got ate away. There was a river up here, that's the channel bed. The lava flowed into it, hardened, cooled, and then it eroded away and kept eroding it to a second level. And then that one, another lava flow came, and then it hardened and it ate it away. And now you see the river bottom now here. How to explain all of, and of course you still got these beds that are coming up at an angle to begin with, that it's all embedded in. So the problem became, how do you explain all of that in one flood? Well, this was one of the other pieces of evidence. And these are just 2 snapshot locations. Over the course of 100 years, they sort of globally began looking around and finding stuff. So the geological phenomenology that they began to see globally, if you start to try to fit it into a worldwide flood, it ain't working. Here are some of those other examples I'll bring up here. The atolls that I was talking about. I don't know if you've heard of an atoll, but it's a volcanic island, like in the South Pacific. There's hundreds of these. I think there are 1,000 or so, where basically a volcano begins to grow at the bottom. This is sort of a cross section. This is looking from the top. This is, if you slice it in half and look below, the volcano would begin to grow from the ocean bottom, grows until it finally, some of them finally pierce through the surface, and you grow into big volcanic islands like this. Well, in time, they'll begin to accumulate a coral reef on the edges here, where the corals will grow naturally in the shallow water because they need to be near light. So you need water no deeper than about 30 feet. Get below that and it can't grow. So they'll naturally do that over the years. Well, the volcano is over like a local hotspot, and all that lava is coming out. Eventually it'll cool down, and when it starts to do that, it'll begin to kind of sink again because the heat's gone, and it begins to drop over time. So what happens is later when you look at an atoll, you'll find that, of course, as it slowly sinks, and we're talking over years, hundreds of years, thousands of years, it begins to sink down. What's happening simultaneously is the volcano itself is dropping, but the coral reef itself keeps growing on top of itself. The old coral dies, but new ones get on top of it to get near the light. So if it sinks slow enough, what's going to happen is the reef will continue to grow, and the island now you'll see from above is now kind of apart from the coral reef that used to be right at the banks of it. Eventually, the volcano itself can disappear above the surface of the waves, and you'll just get this ring around it where the corals continue to grow as it sinks further. So you have this sort of this wall or mountain of old, it's fossil now, debris around here, and if you dig with a like a core, like an oil drill, you can core sample these out, and you'll find the old volcano sunk down below. Now these things will drop down. They're called seamounts. When they get below the surface, it's called seamounts, and they find them everywhere across the South Pacific, especially, that have now dropped below sea level. Some of them are only 200 or 300 feet below, but some have already gone down as almost as much as a mile down below the surface here. Here are some examples. This is an actual, a satellite picture of an atoll. This is Tuvalu archipelago in French Polynesia. The volcano, of course, is all gone now, and all you see is the coral reef around it. Here are 4 other examples. Here's one in process. You've got this volcano here, mountain here, island chain, and then the coral reef around it. But here it's sunk down where it's almost disappeared, and here it's gone altogether. Here's another one where it's looped around and filling in the middle. So how do you explain those from a 1-year flood? Becomes a question. How are you going to fit that in? That's one example. Here are some. These are called joints, not the kind you smoke. This is. These are volcanic plumes, or there are 2 kinds of volcanic activity. You have volcanoes that come to the surface we're familiar with, and they explode out everywhere. But there's also something called plutons. Plutons are when the lava rises, but it doesn't quite make it to the surface. It kind of stops to a certain level, stays there, cools off in time, and begins to kind of shrink apart. We were talking about the volcanoes shrinking down. These plutons will do that too. And when they cool, they start forming these characteristic hexagonal type shape forms. These pillars here. I think you got another example. These hexagonal shapes here that you see are these characteristic shapes. And maybe a little better that way. And what has happened here is this big giant pool of lava that was cooling, but when it cools, it shrinks, so they begin to separate apart into these hexagonal type patterns here. Now the time frames for a volcanic pluton on these sizes to cool become a question. And of course, when you look at the physics of the way things work now, as far as the hot lava, how long does it take to cool? When you got a body that's the size of a mountain, these are only course of, if it's just normal conduction through the surface and water cooling and so forth, takes about 10 to 20,000 years. And so these characteristic elements here take a long time to cool. How do you cool these things fast in a 1-year flood? Here are folds that are these. You see these kind of folded rocks here. Now what's happened here is that these layers were at one time flat and deposited, and the older layers are at the bottom, and they sequentially go up. Eventually, they lithified, and then they began to be pushed. Tectonic forces that move mountains of dirt around began to bend them. If you take a piece of paper and kind of push on the edges, you'll see how it folds over. That's what that represents there too. You can see these folding. So this was laid down, lithified, pushed up, and then eroded again, is what you're seeing here. Here's a close-up. So you see these little inclusions here where it pinches it off. It's called boudinage, like sausages is what they call that here too. But you can see different kinds of layers of rock, different kinds of composition that are in these folds that are here. Here's what we were just talking about earlier is an unconformity. See the history that's gone here. See these layers of rock are all vertical, but they have been ate away. Oh, this is an unconformity here. And on top of it, new layers of rock have been deposited. And the whole thing is lithified, raised up, and it's been eaten away a third time. Just like that first picture you saw with James Hutton. There's Hutton's picture again. I'll put that in this mix here. Here's a big one. This is kind of a disconformity. You do see some layers of rock which are parallel here, but you can see this one right here where it's coming at an angle across this whole area. So the history on this is you've got to deposit these lower layers here. You've got to eat it away and then deposit all these guys, and then you've got to eat away the remainder of the canyon that you see here. Here's some faults. Man for scale. You can see at one time this was laterally continuous, but now the rock is cracked and is shifted or displaced, in this case that much. Here's another example over here where you see how it's been shifted. It's a thrust fault here. This is, I think, mostly a stress fault. It's there. Here's a big one. This is on a satellite picture showing you see clearly these distinct layers were at one time continuous across here. That entire landscape is shifted this much. So how long does it take to lay down those layers of rock, then get them to lithify, bend, fault out, and then erode away? This is called a diaper. These are used in geology. Petroleum engineer Tim Bode, yeah. I was hoping he would have been there when I was on this, but he didn't make it that Sunday. But what's happening here? This is an evaporate. This layer of rock here was actually high concentrated with salts of different kinds. Regular rock salt that you use in your ice cream, but also other kinds of salts as well. They're light and they don't lithify very well. But above that are this overburden of heavier rock that got layered into it. Well, what happens over time, that heavy rock begins to push on the weight of all of that, and we're talking hundreds of feet, begin to push the weight on it to push it up, and makes it, and where there's like a spot where it's weak, it'll basically extrude it, kind of like silly putty, up into that and make these dome type features here. That's called a diaper. The reason oil industry is interested in these is that because some of the layers don't get pierced through, but rather get folded upward, and as a consequence, they become these pocket places where oil can be trapped. Oil which is in these sediments here that rotted away. The oil itself, oil and water don't mix, so it separates out. Oil is typically lighter, it'll float up, so you'll get these pools. So they get their drilling equipment here and they try to drill around these diapers in order to find oil. So they're of very big interest. Now this one is subterranean, and here's some seismic graphs that are used to actually explore underground to see a characteristic set of diapers that are around this area. I don't know the location on that one. This one, though, is at the surface and is eroding away today. That's a gypsum type salt material there. It's extruded upward, and over time it's being eaten away. Eventually, because the salt is, dissolves so quickly in water, quickly in geological time is about 30 or 40,000 years, this is going to disappear, and you'll have a hollow spot in here where the diaper used to be.
How common are these things? Are they? I'm just surprised that I guess they let people try to get the oil out of them. They seem like they're unique features.
They're big in West Texas.
Okay. Okay.
You know those oil dips you see kind of around?
Okay.
A lot of them are because of that.
Okay.
This stuff. Okay, and of course, external magma flows is another thing that's not flood related. Lava and fire and water don't mix. So you've got features that are formed from external lava. And pollutants, that was what I talked about earlier. You have these extrusions of internal, they don't ever get to the surface, but then they get big. This one, you can see the scale of this one. And it's hardened now and is eroding away. Here is Enchanted Rock. If you've been in Llano, that's the Llano Uplift area. That's a big batholith pollutant. It's there too. I've climbed this many a time. Our family goes camping there a lot. And then I have other lava flows here. These are called dikes, where you can see the lava is extruded through this layer right here, distinctly so. Here, these people are in scale. You can see this volcanic lobe push through these layers of rock. This is also a couple of sills that push through. Dikes that push through there.
So can I add something?
Yeah.
Quick? Not necessarily specific about that, but I guess what we're seeing here and kind of the old Earth mentality is that these geologic formations cannot be explained by just the sheer water pressure on top of it. That
Yeah.
something had to have happened laterally or from underneath to rotate stuff. So whether or not the flood happened globally, these still have to be accounted for in a time perspective.
This is why geologists long ago left the diluvian model, the flood model. It's because they're finding all of these and trying to fit them in to what they're seeing. This one right here, for example, has 3 different events in it. You've got this this massive flow out here. Then when it cooled, there is this crystalline flow in white that injected into it. And then later, once that cooled, you see another dike injected in a 3rd time. And then the whole thing has been uplifted and ate away. So you've got 4 different kinds of events that have occurred here that are not flood related. And last, I have impact craters that are not a flood geology thing too. So even though, an impact, of course, is a catastrophic event, but this had to hit rock that was there before it hit. So you've got to deal with the age before the crater hit, then the crater hits, and then you got the eroding away of it. And of course, if you know all your geographical maps of the world, there are not a lot of craters out there. The moon is covered with them. So if you take the premise that whatever got hit by the moon, the Earth must have got hit by the same sort of stuff. Well, we don't have it here. Why not? Well, the erosion element is a big part of that. Now, the flood, the young Earthers, granted, will say, well, the flood did that, wiped it all out. This is evidence for it. And I will tell you, for every argument that a geologist would try to give for an old Earth, the young Earthers are right there to give their plausible counter argument too. And it's like dueling experts in a trial. You get your one expert on the one side for the defense and one on the expert on the other side for the prosecution. Who do you believe? That's really what it kind of comes to. Okay, that was all of that. So let me give you y'all's geology test. Let's see, where were we here? Geological formula. All right, so this is the reason I wanted to use this as opposed to, you will see arguments, for like radioactive carbon dating and other kinds of phenomena, fossils themselves, reverse sequences, and all of that. I have been trying to put together more compelling arguments that are kind of away from that. I think those arguments are valid, but they confuse people. They confuse me when I'm trying to look through, and it's like it's not helping matters to try to clarify. So what I've tried to do is put together material that's strictly physically based, stacking blocks. The old block, the one on the bottom is the oldest, and just leave it relative, and not worry right now about quantitative. Like, this thing is 65 million years old. Let's not talk about that right now. Let's just talk about process. The fact that, we know this had to come first, then the other one. And that's what this is. This is on a geology test here. So, do you see the sequences of events that have all occurred here? These are called folds. These are folded rock here in A. You got these faults here that you can recognize it. You can see the dike cutting across here. There's an unconformity there. Another unconformity here. Layers of rock going in here. And so, as I was describing before, you can, if you saw this in a feature somewhere, give relative ages of where these things are, undisputable, that this must have been the order of sequencing. And that's what you see here. A must have been deposited first. Then B, the plutonic intrusion, B. C, it faulted. Then comes D, the unconformity, ate that away. Then comes E, the layer of rock on top of that.